Every year, billions of chocolate bars travel across the world. They appear on supermarket shelves, vending machines, airports, and convenience stores as if they simply materialized overnight. But behind every perfectly shaped bar lies an industrial system so precise that a tiny mistake measured in fractions of a degree can ruin thousands of kilograms of chocolate. Inside a modern chocolate factory, raw cocoa beans begin a journey through enormous roasting systems, automated mixers, high-speed molding lines, robotic packaging stations, and intelligent quality control networks. Many of these factories operate around the clock, producing millions of pieces every day with astonishing consistency. But how do factories transform bitter cocoa beans into one of the most popular foods on Earth? And why are some of the most advanced automation systems in the food industry hidden inside chocolate production facilities? The answer reveals an engineering process far more complex than most people realize. Chocolate is one of the world's most recognizable products, yet few people ever see the extraordinary machinery responsible for making it. Modern chocolate manufacturing combines food science, mechanical engineering, industrial automation, robotics, thermal control systems, and precision quality inspection. What began centuries ago as a handcrafted luxury has evolved into a highly automated global industry worth hundreds of billions of dollars. Today, chocolate production facilities operate on a scale that would have been unimaginable to early chocolatiers. A single factory can process hundreds of tons of cocoa ingredients every day while maintaining strict consistency in flavor, texture, appearance, and safety. In this documentary, we will follow the complete journey through a modern chocolate factory, from raw cocoa beans to finished products ready for global distribution. Along the way, we will uncover the machines, technologies, and engineering innovations that make large-scale factory automation possible. Everything begins thousands of kilometers away from the factory floor. Cocoa trees grow primarily in tropical regions, where temperature and humidity create ideal growing conditions. Farmers harvest colorful cocoa pods containing dozens of beans surrounded by sweet pulp. These beans undergo fermentation and drying before being shipped to manufacturing facilities around the world. When the beans arrive at a chocolate factory, automated receiving systems inspect incoming loads for moisture levels, contamination, and quality consistency. Massive cleaning machines remove stones, dust, metal fragments, and unwanted materials before production begins. The beans then enter industrial roasting systems. Roasting is one of the most critical stages in chocolate production because it develops the complex aromas consumers associate with chocolate. Large rotating roasters carefully control temperature, airflow, and residence time to achieve precise flavor profiles. Once roasted, the beans move through cracking and winnowing machines. These systems separate the outer shell from the valuable cocoa nibs inside. Powerful air classification technology removes lightweight shell material while preserving the heavier nibs needed for production. At this stage, the factory has transformed agricultural raw material into a controlled industrial ingredient ready for further processing. The next stage reveals where chocolate truly begins to take shape. The cocoa nibs enter grinding systems that reduce them into a thick liquid called cocoa liquor. Despite its name, this material contains no alcohol. Instead, it consists of finely ground cocoa solids mixed with natural cocoa butter. Industrial grinders use enormous pressure and mechanical force to break particles into microscopic sizes. The resulting liquid becomes the foundation for numerous chocolate products. Depending on the final recipe, automated dosing systems introduce sugar, milk powder, cocoa butter, and other ingredients. Computer-controlled weighing equipment ensures every batch follows exact specifications. This mixture then enters refining machines. Giant rollers crush particles smaller and smaller until the texture becomes smooth enough for human taste preferences. Surprisingly, the human tongue can detect particles larger than approximately 30 microns. That means precision at microscopic scales directly influences the consumer experience. Factories constantly monitor particle size throughout this process. Even slight variations can affect texture, mouthfeel, and product quality. What emerges from refining may look like chocolate, but another critical step still remains. Many experts consider conching the heart of chocolate manufacturing. Conching machines slowly mix and aerate chocolate for hours and sometimes days. During this stage, heat, motion, and airflow work together to remove unwanted flavors while developing smoothness and complexity. Inside these enormous machines, rotating paddles continuously move tons of chocolate through carefully controlled environments. Sensors monitor temperature, viscosity, moisture, and processing conditions in real time. The engineering challenge is remarkable. Chocolate behaves differently depending on fat content, temperature, and particle distribution. A slight deviation can dramatically alter the final product. Modern automation allows operators to monitor entire conching systems from centralized control rooms. Advanced software continuously adjusts parameters to maintain ideal processing conditions. The result is a transformation that consumers never see but immediately recognize when tasting premium chocolate. One of the most fascinating engineering challenges in chocolate production involves temperature. Chocolate contains cocoa butter crystals that can form in several different structures. Only one crystal form creates the glossy appearance, satisfying snap, and smooth texture associated with high-quality chocolate. To achieve this structure, factories use tempering machines. These systems carefully heat, cool, and reheat chocolate according to precise thermal profiles. Temperature differences of only a few degrees can determine whether a chocolate bar appears shiny and attractive or dull and unstable. Industrial tempering equipment continuously circulates chocolate through temperature-controlled zones while monitoring conditions using automated sensors. The process resembles a highly engineered thermal balancing act. Every second matters because crystal formation occurs continuously as chocolate moves through the production line. Without proper tempering, even the finest ingredients cannot produce premium chocolate. After tempering, the liquid chocolate enters one of the most visually satisfying stages of the factory. High-speed molding lines deposit exact quantities of chocolate into thousands of molds moving along automated conveyors. Vibration tables remove trapped air bubbles while ensuring complete mold filling. Cooling tunnels then gradually reduce temperature to solidify products without damaging crystal structure. Some facilities produce filled chocolates containing caramel, nuts, wafers, creams, or other ingredients. Automated depositing systems can create multiple layers with astonishing accuracy. Industrial robots frequently handle mold transport, stacking, and transfer operations. Vision-guided systems identify positioning automatically and make adjustments in real time. A single production line may manufacture tens of thousands of pieces every hour while maintaining nearly identical dimensions and weight across every product. This level of consistency would be impossible without advanced automation technologies. Before any chocolate reaches consumers, it must pass a series of inspections. Modern chocolate factories rely heavily on automated quality control systems. High-speed cameras inspect shape, color, surface finish, and dimensional accuracy. Some vision systems analyze hundreds of products every minute. Metal detection equipment scans every package for contamination risks. X-ray systems inspect internal structures without damaging products. Laboratories conduct chemical analysis to verify ingredient composition, moisture levels, fat content, and microbiological safety. Artificial intelligence is increasingly helping factories identify production abnormalities before defects occur. Predictive maintenance software can even detect machine problems before operators notice them. These technologies help ensure that every product meets strict quality standards regardless of production volume. The final stage is where chocolate becomes a global product. Automated packaging machines wrap, seal, label, and code products at extraordinary speeds. Robotic palletizers organize finished cases into shipping configurations optimized for transportation efficiency. Warehouse automation systems track inventory movement using sensors, barcode scanners, and software platforms connected directly to production lines. Some facilities now operate smart factory environments where machines communicate continuously through industrial networks. Production managers can monitor entire operations using real-time dashboards displaying performance metrics, energy consumption, maintenance status, and output levels. Every chocolate bar carries a hidden story of precision machinery, thermal engineering, industrial robotics, and advanced factory automation working together behind the scenes. The next time you unwrap a piece of chocolate, consider the remarkable journey it completed before reaching your hands. If you enjoy exploring the world's most fascinating factories, machines, and industrial technologies, subscribe to the channel and join us for the next engineering documentary.